So now that we've played the dice game and saw how carbon moves around in our atmosphere a little bit, let's go ahead and take a look at what happens when the carbon is released from the fossil fuels. So this is a graph showing you carbon in the atmosphere in the form of carbon dioxide over the past 800,000 years. So take a look at it and see if you can think through the questions. Number one, what do you notice have past carbon dioxide levels been constant? Number two, how might we know what these past CO2 levels were? And then number three, if you look all the way up at present day, 0 years before present, is what we're currently experiencing with CO2 levels normal? So hopefully you see CO2 levels have not been constant in the past. They've always gone up and down. We have records of this from little gas bubbles and ice cores. And if you look at today, or 2019 average, we are well above the average of the past. So if we zoom in, we want to know, well, why? What's happening during our present day, during this time? And so if we zoom in, we start to see the pretty significant rise starts around 1751. And we see it go up pretty dramatically. And if we start to think about, well, what do we know about this time period? What's happening in the world? And I'll let you think on that for a moment. Maybe think to your social studies classes. And maybe you're thinking about the Industrial Revolution, and you'd be right. So around 1751-ish into the 1800s, we are experiencing the Industrial Revolution. We are getting more carbon from the ground, burning more carbon, emitting more carbon in the form of carbon dioxide into our atmosphere. We can also compare our CO2 emissions, or the carbon into the atmosphere, with population, and we see that curved line on both of the graphs very similar. So world population increasing definitely tracks with increase in CO2 emissions. So we can think a little bit more specifically about where the CO2 is coming from, and we can start to see when it rises as well. So I'm going to play a quick visualization video, and I want you to think about where is the carbon dioxide coming from and why there. So when I back up the video to 2010 and I see all these illuminated places, meaning they are emitting a lot of CO2, I notice something. I notice that some of the most populated locations in our world are the ones emitting the most CO2, which makes a lot of sense. So the other thing we can do is we can actually measure, scientists can measure and estimate rates of carbon dioxide given off very specifically. And so they do this in a unit called gigatons. It's 1 billion tons of CO2. And so we can start to actually get a little bit more detailed and specific about where our carbon is going. So I'm going to show you the numbers, and what I want you to do is I want you to go to your carbon model, and I want you to add the numbers to your carbon model. So photosynthesis, we can track that there's 121 gigatons of carbon per year in photosynthesis. With cellular respiration, we can track that there's 119 gigatons of carbon per year. And then when we add in the human factor, burning or combusting fossil fuels, we see 10.5 gigatons of carbon per year. So when I think about that and I put that on my carbon system model, right, I have my 121 by photosynthesis being taken out of the atmosphere. I have 119 going into the atmosphere. And then I have my 10.5 gigatons being released by humans burning fossil fuels. So take a minute and you're going to answer these right on your sheet, not in your notebook. But I notice that photosynthesis and cellular respiration, take a look at those numbers. 121 versus 119, that's pretty close. And it actually would be taking out a little bit more carbon dioxide than's being put in. Question number 2, how does burning fossil fuels change the balance? Take a look at that 10.5 and really think about how we saw this in the dice game, and then try to use the numbers to figure out how does the burning fossil fuels change the balance. And you can go ahead and answer the question again right on your little half sheet. Once you're done with thinking about the numbers on our carbon system model, you can go ahead and cut out your squares and finish up your cause and effect relationship flowchart. Now we have the whole flowchart from fossil fuel use all the way over to air temperatures rising all the way to both floods and droughts. Feel free to come check with me if you'd like to see the order of events from fossil fuels to air temperatures rising, but this is how you're going to wrap up your class time today.